In section 7 of chapter 5, we're going to take a look at factoring those special products that we got when we squared this binomial to get a perfect square trinomial, and then when we multiplied conjugates to get the difference of perfect squares, and then we're also going to introduce a few more. So with that in mind, let's take a look at what we have here. Once again, this is the form of the, standard form of the quadratic expression. And we did some like this in the last section when we factored this, and we saw that it resulted in a binomial square. Well, if that was, then this must have been a perfect square trinomial, which is in this form. So we're going to look at some of the characteristics of it, and this will be an aid to factoring things. So hopefully we went over some of this before. As we look at something, is the first term of the trinomial a perfect square? Is the last term a perfect square? And these are both plus. Now this could either be negative or positive, but if you take the square root of this and get a 4, and the square root of this and get a 3, and you multiply these together and then double it and you get your b term, then that is a perfect square trinomial. So I would suggest, if you think you have one, you might, instead of using 2 parentheses, just use 1, put the square there. And what's the square root of 1? Well, 1, or just plain m here. Now your middle sign here will be plus. And what's the square root of 25? 5. And then you can use that special technique. Square the first, gives you that. Multiply these two together, gives you 5. Double it, gives you 10. Square this term. And this is the reverse of that technique, where if we recognize we have a perfect square trinomial, it will factor into a binomial square. Now we also need to keep in mind that if there is a greatest common factor in each term, we have to take that out and be sure we put it in standard form. And let's do this one here too. Square root of b squared is b, or 1b. Square root of 64, we're going to use a plus, and that is 8. Square the first term, we get this. Multiply these together, double it, we get this, and this checks out. Now in example 2, as we look at it, is there a common factor? And the answer is yes. You could factor out a 3x. So once you do that, does this look like a perfect square trinomial? And it does. First term's a square, the last term's a square. They're both positive. Square root of 4 is 2. Square root of 1 is 1. 2 times 1 is 2, double it, and that. And your middle sign will be negative. So this will be 2a, and then a b. So square this, you get that. Multiply these two together, you get a negative 2ab, double it, a negative 4ab. And square a negative b times negative b is a positive b squared. So this checks out. And then here you would factor a 5 out first. Now another special product we said was when you had the difference of perfect squares. And that would factor into its conjugates. So it's working out that we had some of this before, and now we're recognizing it. So as you look at example 3, we want to factor these into their conjugates. So we'll do them over here. So x squared minus 9 will be x plus 3, x minus 3. For this, again, they're both squares, so you factor them into their conjugates. This will be 4y. You can put the 4y there. And then this is a 3 and a 3. So you're taking the square root of each of these, and then one's plus and one's minus. Now here, you need to factor out a 2 first. So if you factor out a 2, you get a 25 minus 4y squared. Now it's the difference of perfect squares, which will factor into 2, and then its conjugates. 5 plus 2y, 5 minus 2y. And then here, this will be x plus 1/2, x minus 1/2. Okay, and these are just some more practice. As we start example 4, looks like so, and this is a perfect square. So we factor it into its conjugates. P squared plus 4, p squared minus 4. Now if you stopped at this point, Math Lab would count that wrong, and you might say, well, why? Well, because this still is the difference of perfect squares and would need to be factored into p plus 2, p minus 2, and then of course p squared plus 4. Now the sum of perfect squares is not factorable in this fashion, but the difference of perfect squares is. All right, let's take a look at the next one. Now, your first item might be, well, you have to expand that, and the answer is no. You leave it in this form because this is sort of like a squared minus b squared. So we then factor it, x plus 3 plus 6 and x plus 3 minus 6. There we go. So then now you end up with x plus 9 and x minus 3. So this is a little tricky, this one. We set it up as if it were the difference of perfect squares. And in your next course, you're going to use this. Some special things can be done with this, but here we're only asked to factor it. And we see it illustrated here. We simplified that just a little bit, and we got those answers. Okay, going on to example 5 now. As we look at that, oh, you might say that's 4 terms. We're going to factor this by grouping. Well, you are, but it's something you should recognize. Notice if I put a parenthesis right there, I have a perfect square trinomial that will factor into this. And now it's in the form of a squared minus b squared. And this one is worked the same way. You get this plus y, this minus y, and then you just take away the parentheses and you end up with your answer. Now, we are being exposed to a new type of factoring in Objective 3, and that is factoring the sum or difference of cubes. So looking at the model they're giving us, here this is a cube and this is a cube, and it's the sum. This is a cube, this is a cube, and it's the difference. So factoring the sum and differences of cubes. Now there is a recipe for this. At an interesting point, I did this some years ago on YouTube, and it's had like 5,000 hits, so I'm going to give it to you for free right now. So there is the sum of cubes. And how do you go about factoring? Well, there's a recipe to it, and we'll take it step by step. First, you make a parenthesis for 2 items, 2 terms, then a parenthesis for 3 terms. So that's like step 1 of factoring the sum or differences of cubes. They're very, very similar. Now, of course, you'd have to factor out anything that was a common factor in both, but then this is the beginning of it. Now, whatever sign is between them, and here is the sum, you put that in your parenthesis for 2. Now, over in the parenthesis for 3, you put your opposite sign to this. So right there, that's going to be a negative. So we've set it up with 2 things so far. Parenthesis for 2, parenthesis for 3. Again, this sign right there, and its opposite in the middle of the other. Now, you take the cube root of this, which will be a. Take the cube root of this, which would be b. That's the next step. Now, you then square this term, and that goes right here. You multiply these 2 together, and that goes right there. And then you square this term, and that goes right there. And you have factored it. Now, how about if you had the difference of perfect cubes? Well, a parenthesis for 2, parenthesis for 3, whatever sign is there, and again, we're doing the difference, so we put a negative there and a positive there. Again, cube root of this, a, cube root of this, b, square this, a squared, multiply these together, and you get ab, square this, and you get b squared. And you might say, wow, the only difference between these 2 are the signs right there. And remember, the sign comes from, in the parenthesis for 2, this sign, and then the opposite. Now you might have noticed that when I said multiply these two, and it gives you this term, you might say, well, shouldn't that be a positive? Well, by this earlier rule, it's the opposite sign there. So that's a little bit of a challenge. And that is the rule. So let's do this one here. X to the third plus 8. So a parenthesis for 2, parenthesis for 3. This plus sign goes here, and then opposite sign there. Cube root of x to the third is x. Cube root of 8 is 2. Square this, multiply these two together, and in a sense you're disregarding that sign, just using the technique of multiplying these. Don't disregard the sign, because this takes precedent. And then square this. And there is your answer. Now your book goes through this, and that's something you can follow as well. I like the idea of my little recipe here. And we'll do this one as well. Parenthesis for 2, parenthesis for 3. Now, let me give you a moment to fill that in. So a plus sign there, minus sign there, opposite sign. Cube root of this, cube root of that, square this, multiply these together, square that, and there you go. Example 7, p to the third plus 27 q to the third, parenthesis for 2, parenthesis for 3. This sign there, opposite sign there. Cube root of this, p. Cube root of this, 3q. Square this, p squared. Multiply these together, 3pq. Square this, 9q squared. And for this one, parenthesis for 2, parenthesis for 3. This sign right there, opposite sign there. Cube root of this, y. Cube root of this, 4. Square this, y squared. Multiply these together, 4y. Square this, plus 16. Now, here they are giving us the helpful hint. In fact, that's probably where I got to do my little recipe. All right, let's do this one here. 125 q to the second minus n to the third q to the second. So here we have to factor out the q to the second first. Q to the second. Now I have 125 minus n to the third. So I get q to the second, parenthesis for 2, parenthesis for 3. This sign there, opposite sign there. Cube root of 125 is 5. Cube root of n to the third is n. Square 5. Multiply these two together. And square this. And that's what we have. So we have a short lesson, just 20 minutes.